recording should be going. So it's 10. We will get started for today. Let me get the PowerPoint up. Okay. All right. So our topic today is all about Sig Figs, significant figures. And just to let you know, moving forward in this class, whenever we do a calculation, like be it for a test or whatever, I'm always going to look at if you have the correct number of sig figs in your calculation. And the reason why this is important is that when you do experimental science, your instruments have a certain precision. Your instruments can go out to so many decimals. So when you report a calculation in science, the number of sig figs you're telling your reader is how confident you are in your measurement. That is, every single digit you put in your report, you're saying, I'm confident that this digit is correct due to my experimental setup. So we have to be very careful when we're doing calculations that the number of sig figs we have, we're always aware of that, and we always report the correct number of sig figs. So there are some rules to what's a significant figure and what's not a significant figure. So we're going to go over those first. So our first rule is anything that's not a 0 would be a significant figure. So you can see here in my example for rule 1, anything I've colored blue, that's a non-zero number. And if it's a non-zero number that you are reporting, you are saying that it is significant. Rule 2 is any 0 between non-zero numbers are significant. So here we have the 0 between a 4 and an 8 between two non-zero digits, therefore it's significant. These two zeros between real numbers or non-zero digits rather, that means they're significant. So if you're reporting a number and you have a 0 between non-zero numbers, you are saying that's significant. Now, any 0 that is to the left of a non-zero number are not significant figures. So in this number 0.0032, what you are saying is that these first 3 zeros are placeholders, and your measurement is not precise enough to know if they're actually zeros or not. What your measurement is saying is that you're fairly confident that it is 3.2. So 0.00006, all of these zeros are before a non-zero number. Therefore, by definition, they are not significant. However, though, if you have zeros at the end of a number, that is after a non-zero numbers, they are significant. So here our zeros are after the 5, which means they're significant. Our zeros here are after 6, so they are significant. They can be in front of the decimal or after. It really doesn't matter. If the 0 is coming after a non-zero number, we are saying it is significant, right? And when we have zeros after a non-real number, you need to put a decimal point if it is significant. So for example, 1200 here, there's no decimal. So you can only guess if those zeros are significant or not. So if someone reports 1200 without a decimal, you can be confident that 2 of those numbers are significant. You can't be confident that the zeros are significant. If it was written as 1200 decimal, then you can be confident, oh, those zeros are significant. They have been measured accurately. So if you have the number 1200 and you want to show different numbers of significant figures, that's when scientific notation comes into play, right? So I could say 1200, I could say it's 1.2 times 10 to the 3. This would say that I have two digits that are significant, the 1 and the 2, and all my non-significant zeros are being placed in this 10 to the 3. So here I'm saying that the number isn't 1.2, the number is 1.2 times 10 to the 3, but I'm only confident that those first two digits are significant, the 1 and the 2. If I want to make it 3 significant figures, then I add a 0. If I want to make it a 4, then I add extra zeros. So that's what scientific notation can really do for us. It shows us, we have different levels of significant figures. And here's the example I was just talking about. Put a decimal after your number. Now all the numbers are significant. So Sig Figs in calculations. When you're doing calculations, the first thing you need to do is just figure out how many Sig Figs are in each individual number, right? So if we look at our example on the bottom here, it's already been written out how many Sig Figs are in each number. Then when doing calculations with Sig Figs, we have two sets of rules that we care about. We have a set of rules for multiplication and division, and we have a set of rules for addition and subtraction. Something to keep in mind is that when you are doing calculations, your very last step should be rounding with Sig Figs. So here we have, my first example here, we have 3 numbers that are being multiplied, right? And your answer, you can get your answer to many decimals, but the very last thing you do before you report your number is to make sure it has the correct number of Sig Figs. So I said this at the very beginning, but I'll just say it again. When reporting numbers in this class, one thing I'm always going to grade you on is, do you have the right number of Sig Figs? If you don't, you're going to get some points shaved off. Not a lot, like you're not going to miss the whole question if you don't have the correct number of Sig Figs, but I might take off a few percentages from your answer because you didn't report the number of Sig Figs. So let's take a look at these rules then. So multiplication and division is the simplest rule. It's the easiest one to remember. And that says your answer needs to have the same number of Sig Figs as whatever had the lowest number of Sig Figs in your calculation. So in example 1, we have a number with 4 Sig Figs, a number with 5 Sig Figs, and a number with 2 Sig Figs. Remember, this 0 is a placeholder. It's before any non-zero digit, so it's not significant. Therefore, when we do this calculation, our answer needs to have 2 Sig Figs. Then in example 2, we have a number with 5 Sig Figs. Excuse me, I almost sneezed there. A number with 5 Sig Figs and a number with 3 Sig Figs. So we put that in our calculator and we get a very long answer, but then we need a number with 3 Sig Figs at the very last. So any questions so far about our rules? Right. Addition and subtraction is the one that's gonna mess you up It's the one historically students have trouble with. Um, so, and it's a little odd, but the way that addition and subtraction works is that you line up everything you're adding and subtracting so that the decimals are all in the same place. Then you want to draw a line against whatever has the fewest numbers after the decimal place. So here in our first number, we have 3 numbers after the decimal, 2 numbers after the decimal, and then 4 numbers after the decimal. And what you need to do is you select whatever has the fewest number of numbers after the decimal, and your answer has to reflect that. So 0.07 has 2 numbers after the decimal. Therefore, our answer needs to have 2 numbers after the decimal. Here in our second example, we have 1 number after the decimal, 3 numbers after the decimal. Therefore, when we report our answer, we can only have 1 number after the decimal. And where it gets really confusing, as you saw in the quiz for today, is when you have both addition, subtraction, and multiplication and division in the same problem. Then you have to juggle 2 different rule sets. So any questions about those rules? All right, so we're going to do some practice. And we are going to try and get the correct number of sig figs and the correct answer for A, B, C, and D. So at this time, I'm going to let you try to get the correct answer for these 4 calculations, and I'll be doing them periodically as well. But yeah, take some time, see if you can figure these out. If you want any help, feel free to let me know. If you want to check your answer, let me know, and let's get started. So hopefully you've had some time to at least attempt number one. I'm gonna walk through that in case you're not feeling confident, you're feeling lost. So order of operations. So hopefully we all remember our order of operations. Parentheses come first, followed by multiplication, division, then addition and subtraction. So number one, the first thing we want to do is 1.7 times 10 to the 6 multiplied by 2.63 times 10 to the minus 5. Hopefully I did that right. And I get 44.71 when I just do the multiplication part of that, that calculation. Now, looking at Sig Figs, this number has 2 Sig Figs. This number has 3 Sig Figs. The 10 to the whatever, you don't count those for Sig Figs. They're not significant. They're just placeholders for saying that this number is very big, right? Or very small, depending on if the power is positive or negative. So never look at 10 to the power whatever and ever think about Sig Figs. You can just ignore those. So we have number 2 Sig Figs and number 3 Sig Figs, multiplying them. Multiplication and division say that our answer should have only 2 Sig Figs. However, we're not done yet, right? We still have to add it to 7.33. And here's what I was talking about on the previous slide. Even though 44.71, it only has 2 Sig Figs. So we could say we could round that up to 45, but we're not going to do that yet. You only do that at the very last step. And the reason why I'm not rounding yet is because you get what's called a rounding error. If you round at every step of your calculation, you're going to be off by a couple percent because of rounding error. And it might not matter in some applications to have that rounding error. Other applications, it can definitely matter a lot. So we're not going to be bothered with that quite yet. I got 44.71, not 4.471. At least that's what I got it when I did it previously. I can double check if you'd like. Let me just. Sorry, I have to pull out my Excel calculator here. 1 point times 10 to the power 6 multiplied by 2.63 times 10 to the power 5. 44.71. Yep. Okay. So we're not done yet. So we're not going to, whoops, that is the wrong page. So we're not done yet. So we're not going to round quite yet. We need to add that to 7.33. Now what I'm going to do is I'm going to say that as a note to myself, I'm saying this 44.71 has 2 Sig Figs. And I'm going to put that in my calculation. And I'm going to say, that 44, those are the actual significant figures. The 7-1, they aren't. I'm going to keep the 7-1 so I don't have a rounding error, but they aren't actually significant. All right. And so when I add this 44.71 to 52.04, or sorry, 44.71 to 7.33, I get 52.04. All right. Now, the addition and subtraction rule says I need to have my answer have the same number of digits after the decimal as whatever number has the lowest number after the decimal. Right. This is going to be weird to you, but see if you can follow along. 7.33, that's the easy one. There's actually 2 numbers after the decimal. 44.71, there are 0 numbers after the decimal. And you might be saying right now, how is there 0 numbers after the decimal? I see a 7-1 clearly there. All right, take a step back. Remember, I said 44.71 only has 2 sig figs. So if I was done with the calculation at that point, I would say that answer is 45. But I wasn't done with the calculation yet, so I kept it in the long form, 44.71, made a note to myself, that 7 and 1, they aren't significant. The only significant digits are 4 and 5. So it's almost like the 7 and 1 don't exist in terms of sig figs. They just exist so I don't make an error in my calculation. So when I go back and do my last step, I have to remind myself, okay, 44.71, there's only 2 sig figs. That's the 4 and the 4. So I'm not going to look at the 7 and 1 for my addition and subtraction rule. Just like if I was going to multiply that 44.71 in another calculation, I would say, well, that number only has 2 sig figs. Even though I'm writing it as 44.71, it has 2 sig figs. So the answer is 52. Oh, one other thing that I forgot about in rounding, and I'm going to contradict myself from the video. Let's just say if your digit is between 0 and 4, you round down. If it's between 5 and 9, you round up. The 5 is arbitrary. You can argue it anyways, but we're just going to say for 5, you round up in this class. Other classes might tell you different, but any questions about A then? Any questions about the logic there? Right, so I'm going to give you a couple more minutes to work through the other ones now that you saw an example for A. If you have an answer for any B, C, or D, feel free to let me know. Send me a private message if you have an answer, or if you have questions, just let me know. Otherwise, I'll give you a couple more minutes to try and work through these calculations. So I did have a question. If on A, if the answer was 52.5, would I report it as 52 or 53? Like I said, I think in the videos I said like it depends on if the number's even or odd. That's as arbitrary as anything else, and it just gets more confusing. So let's just say if it's a 5, you round up. Just make life easy. All right, so let's take a look at B here. And just as a reminder, for those of you watching on YouTube and here in the live session, do try these problems. It might be a habit for you to say, these problems too hard, I'm not gonna try, or I'm gonna go look on Facebook or something. Once he puts down the answer, I'm gonna copy the answer and then I'll learn it. I'm gonna tell you right now, you're not gonna learn it that way. The only way you learn something is by doing it, by putting in the hard work of doing it. Like, you can't watch somebody build a house or shoot a basketball and be like, yeah, I saw him do it. Now I know how to do it. So I'm awesome. The only way you learn how to do something is by doing it. So please do use this time to try these. And if you don't know how to do it, that's what you need to ask me, because I don't know you don't know how to do it unless you speak up, and always feel free to reach out to me. All right, for B, we have 568.99 minus 232.1. So this is addition and subtraction. So I'm going to line up the decimals, and I'm going to draw the line after whatever number had the fewest number of decimals. So that is 232.1. So my answer should only have one decimal. So when I do this, I get 336.89. Again, like in A, I'm not going to round until I'm done with every single calculation. What I'm going to do is I'm just going to make a note to myself and say, this is significant. Everything to the left is significant. So in total, this has 4 significant digits. That 9 is not. Although this is kind of a moot point, because we're going to take this number, divide by 5.3. We're doing a multiplication and division now. We're dividing something that has 4 sig figs by something that has 2 sig figs. So our answer should have only 2 sig figs. When we do this calculation, we get 63.56. I need to round. That goes to 64. So that's B. Let's go right on the C then. C. 9443 plus 45 minus 9.9. Do the same thing, draw my line after the decimal. My number will have 0 things after the decimal, because both 9443 and 45 have nothing after the decimal. So when I do this addition and subtraction, I get 9478.1. Again, I'm going to keep that 0.1 for calculations and say this is where my significant figures end on the 8. So this number has 4 sig figs. I'm going to multiply it by a number that has 2 sig figs. And you get a big number. At least I got a big number. 7.7 times 10 to the 10, which has 2 sig figs. So before I move on to D, and I guess I can give people like a minute or two to do that or catch up. Now that you've seen me do 3 of these, are there any questions so far about any of the logic here? Any things you're having trouble with? Anything you didn't follow? All right. What is it in the parentheses number 2? What is the answer for B in the parentheses? That's 336.89. If that's what you mean. You're talking about parentheses here. That calculation is right there. All right, so I can go on to D then. Am I multiplying 94718.1 by just 8.1? It's 9478.1. And you're multiplying by 8.1 times 10 to the 6. Do not forget that number. That number is very important. If you drop that number, you're going to be off by, what is it? A factor of 1,000,000? Yep. So that 8.1 times 10 to the 6 just means this number is 8.1 million, I think. No, divided by 5.3, how did I get that number? So for B, when you do subtraction, you get 336.89, and then divided by 5.3. That's how I got the divided by 5.3. Wouldn't C be 7 times 10 to the 11 because the multiplication number only has one sig fig? The multiplication number has two sig figs, 8 and 1. So I'm calculating the 8.1 problem, then multiplying that answer with the other one. So what you do is for C, you do what's in the parentheses first, right? And you get that number. You write down or tell yourself or make a note, however, how many sig figs that has. Then you multiply that by whatever's next. So in the parentheses, is that 2? Oh, you mean underneath the 5.3? That's saying 2 sig figs. This is 4 sig figs. I'm just writing down how many sig figs there are. That's what the 2 is. Anything else before I move on to D? And what I will do as well is I'll search for like some more practice problems, and I'll put those in a Word document like I did for unit conversion. Put that on Blackboard in the test 1 folder, so you can have more practice over this. Practice to your heart's content. All right, D, 3.14 times 2.4367. This number has 3 sig figs. This one has 5 sig figs. So we want to, our answer needs to have only 3 sig figs. So when I do that, I get what, 7.6512. Again, don't round until the very last step. Just make a note to yourself that only these 3 digits are significant. The 1 and the 2 aren't. That's important when it comes to the next step because we're doing subtraction. I draw a line after whatever has the least amount in the decimals. 2.34 has 2 numbers after the decimal that are significant. 7.6512 has 2 numbers after the decimal that are significant based on our rules. So our answer is going to have 2 numbers after the decimal. and then it should just be 5.31. So again, when doing multiplication and division, when doing multiple steps, make sure you know which rule goes to which application. Make sure you are always keeping aware of, which answers have what number of sig figs. And also don't round to the very end or you will get the wrong calculation. Most of the time in these examples, you might not, but moving on in your careers, if you want to do like any sort of science applications, you could be off by a couple of percentages. Like I said, some applications might not matter. If you're making a part for the spaceship, that's gonna matter a lot. If you're giving medication to somebody and you want the pressure, the osmotic pressure in the transfusion that you're giving them, that couple percentage points could matter quite a bit. So we have to be aware of those. Any questions about our lovely Sig Fig calculations? And in lab and on tests moving forward, just let you know that I will be watching these, your Sig Figs. All right, so moving on then. The last thing we're going to work on is more unit conversions, but this time it's going to be a little more complicated because the units we're going to be converting are going to be squared units. Oh, so there's a question. So once you do, for example, addition and the answer only has 2 sig figs, and then you multiply with the number that has 4, you would only show 2 sig figs. Yep. Multiplication and division, the rules are you pick the number with the lowest number of sig figs. So that is correct. All right. So I'm going to actually do B as an example here because A is more or less straightforward, hopefully. So how do we do conversions if we have units that are squared or units that are power of 3, power of 4, power of 1,000,000, whatever? All right. So I'm going to do B. The first thing we need to do is, well, let's just read it. I'm converting squared meters to squared kilometers. So we go to our table, and remember, you're not going to have that table of metric conversions on the test. So that's something we need to learn. Flashcard to your friend for that. But I do know off the top of my head that there are 1,000 meters in 1 kilometer, right? So that's one of the pieces of information we need to know if we want to do conversions here. Also, something else we need to know is what does meters squared actually mean? Well, meter squared means meters times meters. Kilometer squared means kilometers times kilometers. All right, so those 2 pieces of information, we can now do our unit conversion from meter squared to kilometer squared. So we have 115, and what I'm going to do here is I'm actually going to write it out in the meters times meters form. Just remember, the way I wrote it out there, it's equivalent to saying meter squared. It's the same thing. Then we do our train track methods. All right, so I want to convert from meter squared to kilometer squared. So I have 2 meters at the top, and I have a conversion that will give me meters to kilometers. So the first thing I'm going to do is cancel out one of those meters. So meters at the top, meters at the bottom, they cancel out. And the unit I'm left with now is meters kilometers. So I have 1 meter left at the top, 1 kilometer left at the top, but my unit isn't meter kilometers. My unit is kilometers squared. So I need to do that conversion again. I need to get rid of the meter at the top, and I need to convert to kilometers. So meters cancel. I'm left with kilometers squared at the top, or kilometers times kilometers. Now you can do your calculation. So remember, you take everything at the top multiplied by together. So that'll just be 115, and you divide it by what's on the bottom. So you divide that number by 1,000, then you divide it by 1,000 again. And what we should get is 1.15 times 10 to the minus 4 square kilometers. So that's how we can do unit conversions when we are dealing with squares and to the power of 3, or cubes. That's what I was looking for. Squares or cubes or tetras or pentas, whatever. So let's all take a minute, see if you can do C. Hopefully you can do A at this point. If not, well, try to do A as well. And if you're feeling confident in these, go on to D. But I'll give everybody a few minutes to do that before I come back with the answers. Again, please do try to do these. The only way you will learn is by trying these yourself instead of just watching me do it. So let me do A real quick, as that one's relatively straightforward. Liters to cubic centimeters. Get my pen back out. 2.7, whoops, 27.8 liters. Why did I write a 4? That's supposed to be an L. Liters, and I want to convert that to cubic centimeters. Well, there's 1 liter and 1,000 cubic centimeters. So that's relatively straightforward. Just multiply those two together to get 278 000. I might have missed a decimal there. 1 sec. Let me recalculate that. Yeah, I did. I missed a decimal. 27,800. So we do have a question. For A, would we write out 1,000 cubic 3 divided by 1 liter 3 times? Nope. Oops, sorry. It's because that liter is a volume. Well, there's a conversion directly from liters to cubic centimeters already. So we don't need to write that one out 3 times because it's already done. There is a conversion for meter squared to kilometer squared, but that's not on our table really, and that's not something easy to memorize, at least for me. Meters to kilometers make more sense because it's a kilo. So kilo is 1,000. So it's a kilometer. So that's why I did it twice. If our conversion was 1 liter equals, what would it be? 10 centimeters. You would have to do it. Well, that wouldn't even work. You can't do it 3 times. The reason why you can't do it 3 times is because liter is raised to the power of 1. cm is raised to the power of 3. What would need to happen to do it 3 times is you need some weird unit like liters cubed. And then I would have to say 1 liter is 10 centimeters. Then you would do it 3 times. But the way that the units work out, liter is already to the power of 1. So you can't do it 3 times. Otherwise, you get some weird unit. So yeah. Okay, C. So meter to centimeters. There are 100 centimeter in 1 meter. So 195 meters squared. So 1 meter is 100 centimeters. So meter cancel out. One of the squares cancel out because remember, meter squared is just meters times meters. Do that again. 1 meter is 100 centimeters. Meter cancels out. Meter cancels out. My unit is cubic centimeters now. That's exactly what I want. And the answer is 195,000 cubic centimeters. Any questions about A, B, or C? All right, and D, we have a few minutes left, so I will polish that one off. On A, how did you get 1.15? I didn't, that's B. But what I did there is I just put it in scientific notation. So your answer could be different than mine on your calculator. Like you could have 0.000115. That's the same thing. I just put it in scientific notation. 115 divided by 1,000 divided by 1,000. All right, so D, let's take a look at that. Runner wants to run 10 kilometers. She runs at 7.5 miles per hour. Miles per 1 hour. So if you weren't sure, miles per hour means how far you go in 1 hour, right? Miles per hour. It's a unit hopefully we're all familiar with. We can use that same idea here when doing unit conversions. And the question is, if I run 7.5 miles per hour and I want to run 10 kilometers, how many minutes will that take me? So the other conversion we need to know is 1 hour equals 60 minutes. All right. So a common question I always get here is, where do you start? Do I start with the 10 kilometers or do you run with the start with the 7.5 miles per hour? In all honesty, it doesn't really matter. I'm going to start with the simpler unit. I'm going to start with the unit that doesn't have anything in the denominator. I'm going to start with the 10 kilometers. It's the number I was given first. It's my goal. It doesn't have anything in the denominator. I'm going to start with that and see if it works out. All right. So the idea is I want to convert this distance to a time, right? So I know the distance I want to run. The question is, what is the time for that? And I need a conversion between distance and time. Your conversion is speed or pace. Your pace is 7.5 miles for every 1 hour. So this will allow me to convert from miles to hours directly. The only problem is I don't start in miles, I start in kilometers. So my logic for this is I start in kilometers and I'm going to go and I want to go to minutes. That's my end goal. I already saw in my pace, I can convert directly from miles to hours. So the first thing I need to do is to convert from kilometers to miles. And I can do that because I was given that conversion. Once in miles, I can convert to hours because of my pace. Then, since I know 1 hour is 60 minutes, I can convert between hours and minutes. So I'm going to do this. So just logically, based on my logic, I want to convert from kilometers to miles. Cancel kilometers. I want to convert from miles to hours. Cancel miles. I want to convert from hours to minutes. Hour at the top, hour at the bottom, they cancel out. So without putting in any numbers, I can set up my train tracks in such a way that my units are correct. This is one of the great things about doing unit conversions this way, in my opinion, is that without any numbers, I can just logically figure out what type of conversions I need to do. And as long as I have minutes at the top, which is what the question is asking me, I know I did something right, or probably did something right. All right, so that's my path. Let's start filling in those numbers. So my conversion from kilometers to miles, 1 kilometer is 0.621 miles. All right, my conversion from miles to hours, that's my pace. I have 7.5 miles in 1 hour. My conversion from hours to minutes. For every 1 hour, I have 60 minutes. Done. Now I just need to multiply everything at the top, divided by everything at the bottom, and also be aware of my Sig Figs. That 10.0 has 3 Sig Figs. 7.5 has 2 Sig Figs. 0.621, 3 Sig Figs. 60 point, it can actually go further, 3 Sig Figs as written. So things like conversion between hours and minutes, you really don't count the Sig Figs. I did here just to remind us of the Sig Fig rule, but that's an exact number. By that, I mean I can write as many zeros as I want, and that will always be true. Like 1.0000 hours equals 60.0000 minutes. With conversions like that, you're certain of the number. So the significant figures are infinite. When looking at Sig Figs, the only one I really care about is that 7.5 and my distance. Those are the variables that were given in the problem. So those is where I'm going to get my Sig Figs from. So my answer should only have 2 Sig Figs. So now I can just do my multiplication. Multiply everything on top, divided by everything on the bottom. And I get, what, 49.68 minutes. This only has 2 Sig Figs though, so I round to 50 minutes. So at a 7.5 mile per hour pace, you can do a 10K in 50 minutes, which is a pretty good pace. So I only care about Sig Figs when the number are given. Rule of thumb is if it's a conversion, those you generally don't care about those Sig Figs. There are exceptions to that, but generally in conversion factors, like minutes to hours, those are exact numbers. So the Sig Figs are infinite. Something like I want to run a certain distance or my speed is that, those do have Sig Figs to it. So yeah, generally you want to look at what's given to you. Ignore the conversion factors for Sig Figs. Any other questions before we wrap up for today? If not, I will, as always, post the homework on Pearson. Remember, your first homework assignment is due on Friday, so make sure we do that. So yeah. So there's a message from Sarah about more practice. So tomorrow from 12 p.m. to 1:30 p.m. And I'll write down your email in case people are watching this on YouTube and can't see. So Thursday. All right. So there's our SI session. Sarah, do you also want to put that as an announcement on Blackboard? That I think that would help people as well. In case people, I know people will turn off the video before the end of it. Otherwise, I'll put a homework up. If you do have questions, please. You had a question about today's quiz? Sure. Shoot, I got time. If you need to head out, feel free to head out. I don't have any more announcements to make other than homework on Friday. Oh, so the question of how many Sig Figs when doing this? Yes, this is the one like everyone gets wrong. It's a tricky one. So the question on the quiz is 143.7 minus 121 multiplied by 2.06 divided by 0.600. How many Sig Figs are in it? Okay, order of operations. We need to do the thing in the parentheses first. So I need to do 143.7 minus 121. Again, it's addition and subtraction. So I draw my line. This number has one digit after the decimal. This one has 0. So my number needs to have 0 digits after the or 0 numbers after the decimal. So I'm going to just do this calculation really quick here. So when I do that, I get the answer of 22.7. But remember, my answer should not have any digits after the decimal. That's not significant. So this number only has 2 Sig Figs. The 2 and the 2 are significant. The 7's not. If I was going to end right there, like I didn't have to do any more calculations, I would round this to 23 and say 23 is my answer. All right. So that first calculation gives me something with 2 Sig Figs. I'm multiplying it by something with 3 Sig Figs. Well, I'm doing multiplication and division now. So the rule says my answer needs to have 2 Sig Figs. So from this, so for our first multiplication, this only has 2 Sig Figs. Then I'm going to divide it by something that's 0.600. 0.600 has 3 Sig Figs. So I'm taking a number that has 2 Sig Figs, dividing it by a number that has 3 Sig Figs. Again, multiplication and division. My number should have only 2 Sig Figs. So the answer to that quiz question was, how many digits are in my answer that are significant? It's 2. So that quiz question is basically what we did for question 1. All right. So with that, I'm going to let everyone go. If you do have other questions, feel free to email me. Other than that, have a good one, everybody.